What's Yeah. So first question, do you guys trust your common sense?
I hope so.
Right? I mean, it's what keeps you alive, so everyone should, right? So I have two very easy questions to see if people do trust their common sense. So let's start with the first one. So I have a box truck here, and it's completely sealed, obviously. Like, it's closed and everything. And there's a bowling ball inside, hanging from a rope inside. So one of these box trucks is at rest, one is accelerating forward, and one is accelerating in reverse. So out of these three, which one is at rest?
I would assume it's B.
Yeah, it is B. You guys got it. What would you say B though? Yes, exactly. So which one's accelerating forward?
I would assume A. It might be C, but my assumption.
No, you got it. It is A. Yeah. And the reason why do you think it's A, if I may ask?
It's so that when you're running, when things drag, you tend to pull back, and even if you have something hanging off your car, it swings off that way rather than going forward.
Yeah, it's just like for the same reason you get pushed back in your seat when you accelerate. Exactly. It has to do with inertia. So this is trying to remain in its position in space, and then the whole truck is moving forward and is being left behind, pretty much. You know. All right. So you guys got the first one. So the second one is pretty similar, but instead of a bowling ball, it's a helium balloon. So that's the only difference in this one. So out of these three, which one is at rest?
B, I would say B.
Yeah, and it's for the exact same reason as the first, obviously. So which one's accelerating forward?
I would still guess A.
A? Which one? A? Oh, and this one's actually C. So, and the reason why it's C is because helium is obviously less dense than air. So when you accelerate the container, in this case the truck in this direction, all of the air that's inside as well, it's also being pushed in that same direction. And because air is more dense than helium, is able to push it in the same direction that the force was applied. So buoyancy, you guys heard of buoyancy, right? When something floats in water, for example. So if something is less dense than the medium that surrounds it, that's always going to follow the direction of the force, because the medium that surrounds it is able to push it. You know, so here I can demonstrate that here, for example. So this is a buoyant object, obviously, it floats in water. If I accelerate in this direction, what direction do you think the ball's going to go?
Probably to the right. If we're going that direction.
Yeah, same direction as the force. So it hits this side of the ball, you know, when I accelerate. So again, that's just what buoyancy is. It's a chain reaction of a force. So here, I did this experiment myself in a cargo van.
Yes.
I want to see if you guys can tell which direction did I accelerate this. So instead of a bowling ball, I used an apple, and obviously the helium balloon as well. So did I accelerate to the right, or did I accelerate to the left?
To the right.
To the right, obviously. Because obviously not only does matter show you the instant I accelerate, but it also shows you the direction I accelerate. Again, because buoyancy follows that direction, right? So I did it in a smaller scale like this, with a container filled with water, and a ping pong ball and a steel ball. So obviously the ping pong ball is buoyant and the steel ball is not. So what direction would you say I accelerated here? To the right or to the left?
To the right.
Exactly, because that's the direction buoyancy is going, you know. So perfect, you guys got it. So one last one.
Yes.
I did a vertical acceleration. So I was holding a water bottle like this with a ping pong ball and a steel ball, and I accelerated one of these water bottles down vertically. So I want to see if you could tell me which one of these two did I accelerate down vertically, the one on the left or the one on the right?
Like you mean like through?
Yeah, down. Which one did I accelerate down vertically?
Maybe the one on the right?
Yeah. It's obviously because that one shows a change. Again, matter reacted to the acceleration. You know, the buoyant object got pushed down and then the steel ball got left behind. Yeah, because the bottle's moving down. Yeah. So let me ask you guys this. If I was holding this bottle, right, like this at rest, and I just simply released it, do you guys believe gravity pulled it down to the ground? Yes. Okay, so the one on the left was actually free fall. That's exactly what I did. But we see that matter didn't react to that acceleration. Because I don't know if you guys knew, gravity is just the theory. So a physical downwards acceleration or a physical downwards force has never been detected. Because acceleration requires a force. And the force will always cause pressure, which will cause the buoyant object to move and react. So matter will always react to pressure. But in free fall, there is no pressure or force. So that's why gravity is just a theory, because it has never been proven. So what's happening, right? Why do objects appear to go down then, right? So if we understand buoyancy follows the direction of the force, if I have a helium balloon here on Earth and I release it, what direction does it go?
Up.
Yes, it goes up. Why do you think it goes up?
Probably due to the density you were talking about? Or...
Yeah, it has to do with the density. Obviously, it's less dense than air. So the air is able to push the helium up because the air is more dense. Now, in this example, it was the truck that created the force to push the air to push the helium. So here on Earth, what's creating the force to be able to push up the air to be able to push up the helium?
what's creating the force?
Yeah, what's creating the force here on Earth to be able to push up the air, to be able to push up the helium?
I'm not too sure.
No, so it's actually the ground itself is pushing up on you right now.
Okay.
So gravity is not a pulling force of the Earth; it's a pushing force of the Earth. So that's why a pulling force of gravity is just a theory, because the reality is it's a pushing force of the Earth. So when people say, "Well, how are we stuck to the Earth?" Right? It's not that we're being pulled down to the Earth; it's that the Earth is constantly pushing up against you right now. So that's why we're stuck to the Earth, because it's a constant push up. And that push up of the Earth is what creates the pressure here in the air, and then that's able to push up helium balloons. You know,
is it kind of like you're trying to say they're talking about physics, like the way this table's able to hold stuff because of the amount of force you're putting down is pushing back up? Is it kind of like what you're getting at, or is it different?
So that's what explanation of gravity. So they say that things get pulled down, and then there's an upwards push
back.
Back. But the reality is that the upwards push can only happen if the Earth was literally moving up. And then this downwards pull that they're claiming, or this downwards force, has never been measured or detected. So that's just fantasy. So a gravitational field doesn't exist. So the gravitational field is fictitious, because the real force is the Earth pushing up on us right now. And that's what gives us the illusion that there's some kind of gravitational field here. But the force is a push of the Earth. So the Earth is literally moving up through space right now. And that's what gravity is. You know, the Earth's motion up. So that's what gravity. So if we were to accelerate the Earth even faster, guess what? We're gonna get stuck. We're gonna get heavier. So that's what gives us weight, and that's what gravity is. It's literally the upwards push of the Earth. So let me ask you guys this. So you guys believe the Earth is a ball, right? This is the real reason why I'm doing this. So you understand that on a ball, up is relative, right? In other words, if you're standing here, up will be this way. But if you're standing down here, up will be like in the opposite direction from this person. So in every direction away from the center will be up on a ball, you know? So if we could prove that the ground is literally moving up, which is what's creating buoyancy here on Earth, and that can be demonstrated, if we could prove that the ground is literally moving up, how can the Earth move up simultaneously in every direction if it was a ball?
Okay, so you're saying that you don't believe that it permeates from all directions?
Yes, so I'm claiming that the Earth can't move omnidirectional. But if it was a globe and we could prove that the ground is moving up, then the Earth will have to be moving omnidirectional if it was a ball to be able to push up.
If we go with the assumption that we're being pushed up rather than down.
Yes, if we could prove that, how would that work from a globe?
In that instance, then we can prove
it wouldn't work, right? Exactly. So in order for people to believe in the ball Earth theory, they first have to believe in the theory of gravity being a pulling force. Because again, if we could prove it's the other way around and it's the Earth literally pushing up and not pulling us down, then the whole globe Earth concept will fall apart. Because gravity is the number one, I wouldn't even call it proof, I would say, and the number one explanation that the globe Earth has. Because without gravity being a pulling force, they can't explain like orbits, they can't explain how people stick to the Earth, they can't explain, you know, anything, how airplanes fly level over a ball, in other words, without having to adjust for curvature. They say gravity autocorrects. So again, gravity...
So what do you mean with the flying?
So airplanes fly level over the Earth. So that means that they're flying straight, level meaning horizontal. But gravity proponents, globe Earth proponents will say, oh, that happens because the gravity, it's autocorrecting. So because the Earth has to curve, right? If you're flying straight, you have to bend, you have to point the nose down to continue with that curvature, right?
Sure.
But airplanes don't do that. So the explanation for that is, oh, gravity autocorrects the airplane. So that's why you never have to dip your nose down to go over a curve. And that's why airplanes just fly straight, because gravity, you know, but again, gravity is just a theory. It's just the theory that's used to explain away everything that doesn't make sense.
So is there a way that you guys can push that there is something that's moving the Earth up and pushing us up? Oh.
Yes, so that we prove that through buoyancy. So just like I showed in this container, for example, in order for the helium balloon to get pushed in this direction by the air that's more dense, the air also has to be moving in that same direction through space. There's no way for the air to be able to push a helium balloon in any direction if the air's not moving in that same direction as well. Does that make sense?
I'm trying to
so if the air is pushing the helium balloon, for example, right, in any direction,
right?
So
the air is basically heavier.
So the air is heavier. So, but in order for the air to be able to push the helium balloon in any direction, the air also has to be in motion in that same direction. Does that make sense? So, for example, like if a leaf gets blown in by the wind that direction, that means the air is blowing in that direction. There's no way the air could be blowing in this direction, but pushing a leaf in that direction. That makes sense, right? So if we understand that the air is a direct correlation to why helium balloons rise, or even lighter gases, then it's obviously the air pushing on the object, right?
But isn't it also that the balloon is tethered to like an object that's moving?
No. Well, if it is tethered, so it doesn't just hit the ceiling in this scenario.
Yeah.
But if it wasn't moving, it would just remain parallel.
Yeah.
But as soon as I apply a force and the air starts to move in either this direction or this direction, that motion of the air through space is what pushes anything that's less dense in that same direction.
Okay.
So if we see a helium balloon move up, it's literally the air pushing it up. So we understand that the air has to be moving up through space to be able to push up the helium. So the air atmosphere here on Earth is literally moving up through space. And so what's creating that push up? That's the point, right? To be able to push up buoyant objects. Yeah.
But doesn't also like the states of matter also have something to do with what goes up and down?
Yes. So if something is more dense than air, then the air is not thick enough to be able to push it up. So just like with the bowling ball experiment, it gets left behind, right? From the container. So when you release something that's more dense like this, the air here is not dense enough to push this up like a helium balloon. So the Earth just comes up to meet it. So when we release this into free fall, this doesn't accelerate down towards the Earth. It's the Earth that comes up to the object. So that's what's happening. So because we're constantly moving up, as soon as something that's more dense than the air is not connected or tethered to the Earth somehow, it just starts to fall back. It falls behind now. It doesn't necessarily fall down. It looks like it falls down because everything's moving up. So right now, because we're connected to the Earth, we feel that pressure under our feet. We're moving up right now. So anything that's not connected to the Earth, it just appears to go down because everything else is moving up. So that's the reality. That's what physics shows us, in other words. So gravity, again, they want us to believe that there is a gravitational field, again, a fictitious force field, to basically lie to everyone about what the Earth actually is. Because again, if we could prove it's the other way around, it wouldn't work. So the Earth, again, it's a level plane, and it's just moving in one direction, which is up relative to us. Because again, no piece of matter could move omnidirectional, or even in two directions at the same time. Like you can't move this front and back at the same time. You would have to cut it in half and move it. So the globe Earth wants you to believe that's possible, with it pushing up. But again, that can easily be debunked. So if I was to ask you guys respectfully, what's the number one proof or reason that makes you believe the Earth is a ball?
The Earth is a ball?
Yeah, why do you guys believe the Earth is a ball?
Well, one, obviously we can't, pictures, that we've seen. Just like we can understand that how it can appear like flat now because of it's such a huge scale.
Yes.
Compared to a ball. Like if you were to get like a big ball even and to put something like a speck, you can understand how the speck could, in that perspective, be flat. And then like even an airplane, the size, the ratio comparison, that although it might not be curving down, the way, or at least to my knowledge, I don't know,
sure.
Airplanes, they travel is that it depends on the distance they have from the ground. So long as they maintain that distance, that's why sometimes when they're flying, they're not necessarily pointing their nose down, but that distance changes. That's the point of the pilot's job or the system's job to maintain that distance consistently. So there is some motion to whether it be up or down, just to maintain that distance. So. Just an airplane argument, but yeah, my main reason for thinking the Earth is round, it's just because just conceptually it makes sense. Just when I see balls and examples, and based on the evidence we have in research, and it could be fake, but based on the science that I've seen, it seems to be real. And then just by looking at the moon as well. Okay,
you said pictures first, right? Now I'll answer that first. So, just before I get into that, if I showed you a picture of me walking on water, or a video, we'll go with video. If I showed you a video of me walking on water, would you believe I could do that? Would you believe I can actually walk on water?
Probably see it in person.
Now, here, let me ask it a different way. Would you believe I could walk on water if I showed you a video, or would you conclude that I'm using some kind of trickery, whether it's with camera trickery or using mirrors or something?
I think there's a possibility for anything, but I would highly suspect some sort of trickery.
Why would you suspect that I'm using some sort of trickery?
Because I've never seen or heard of that before.
Well, could we agree that defies physics? Somebody walking on water? So even if you show me a realistic video of it, first of all, I wanted you to show me in person, but second, obviously that defies physics. So it's like somebody showing me a video of walking through walls, for example, right? I'm not going to believe that. It's impossible. That defies physics as well. So the globe Earth actually defies physics as well, not only with gravity being a push, not a pull. Do you know the radius of the Earth? Because I know you said that it's so big that...
I did at one point. I don't know anymore.
Okay, so it's 3959, allegedly. So they have to give us these numbers because they are claiming that they have satellites orbiting the Earth, right? So they need to know the radius of orbit. So they need to know the radius of the Earth if they're supposedly going around it. So they have to give us these numbers. So 3959, obviously if we multiply that times 2, we get the diameter, and then we can calculate for the circumference. So the circumference of the Earth is 24,901 miles. That's around, the distance around. So based on the dimensions of the Earth, there has to be curvature every mile, and every mile it increases. So in the first mile, there's an 8-inch drop Second mile, 32 inches. And by the third mile, there should be 6 feet of measurable curvature. So how do we measure for that curve, right? To see if it's actually there. There's actually a very easy way to do it. So if we went to a giant lake that was miles across, once the water's contained and at rest, if we build a level structure over that body of water, the water is going to show that it's going to be parallel to anything horizontal above it, because the physics of water shows that once it's contained and at rest, the surface always collapses and forms an equal surface, which is level, which is horizontal. They're trying to tell us that the surface of water and the surface of every lake here on Earth is bending 8 inches per mile squared. So they're claiming that between the starting point and the end point, there's going to be a 6-foot drop from the starting point to the end point of the surface of water, which is a physical impossibility when we're talking about the physics of water, because water, again, doesn't have a form. It conforms to the shape of the container, but the surface always collapses and forms a horizontal, right? So this will be the number 2 proof to debunk the globe Earth, is the fact that there is no measurable curvature or physical measurable curvature of the Earth.
I have a question. So what do you say when they talk about these ships and they have like telescopes, you know, like really refined telescopes, and they don't just peer off into the distance? They say it actually goes downward. Maybe not. I don't know if it goes down to that degree, but they describe that the ship is like they're going downwards into the abyss.
Yes. So people think that the horizon is the curvature of the Earth, and boats go over the horizon, right? People say they do appear to go over the horizon, but we do have a limit to how far we can see. So I don't know if you knew that. So like, for example, when you observe an object and it gets further away, it starts to appear to shrink at a distance, right? So there is a limit to how far we can see, and the horizon is simply the limit of perspective. So it's the limit of your field of view. So anything that goes beyond the horizon, your visible horizon, just appears to go beyond that limit, but it's not going over a curve. It's just going out of view.
Okay.
Yeah, so that's what's happening. Because when you bring out a camera, a powerful zoom camera, and you zoom into that boat, you're able to pop it back into view.
Okay, and then my last question, only I know this because like my dad was in the military, that there's like a lot of satellite imaging that he was able to oversee, or had people who he knew oversee, and they proved that like where the continents were in relation to each other, right? Okay. And then so we can agree on that, right? That they have a certain relation to each other.
Well, I don't know if you knew, a 100% accurate map of the Earth doesn't exist. So all these
I'm aware.
So all of the projections that we have are just projections. Mm-hmm. Nobody has an actual 100% map of the Earth.
But we have like a close enough relation.
Sure, you could say that, yeah.
And then based on that close enough relation, like I know like he himself traveled from like our coast, like California, to Asia, mm-hmm. and then how would you explain how he got there? Rather, because you know they were able to track where they were by echolocation stuff out of the ocean. They have like really like cool satellite imaging. Yeah. How would you explain that they got from one end to the other without circumventing all around? And they can prove directly that they did go in a straight path.
Yeah, so they use GPS, obviously. Nowadays, people just use GPS. They just follow coordinates on a projection, again, which is not a real thing. But they follow 2 points on a projection, and that's how they navigate, right? So that would work either or. I don't know how that would prove that the Earth is a globe, in other words.
That they went in like a straight path?
You're talking about circumnavigation?
Yeah, but basically they're able to go across the globe rather than just, going across the other continents.
Right. So here, let me show you these images here real quick. So I'll explain to you. So obviously, these are official NASA images, by the way. Mm-hmm. And just food for thought, they actually admit they don't have genuine photographs of the Earth. So every photograph of the Earth that they show us is just an image, not a photograph. So they admit they make them in a computer, so they're all composites. Okay. So the excuse for that is that, we can't get high enough to take a full picture of the Earth, so we just take strips of imagery and stitch them together and Photoshop them in a computer, and that's why we don't have a real photograph of the Earth. But in reality, it's because the globe Earth doesn't exist. So, but that's the excuse they give us. Now, when it comes to navigation, obviously the north will be here, right, on a globe. And you're saying that they're going from like here, like around this way?
No, from here, this way.
This way, okay, this way. So here's the thing: if you have a globe and you just simply open it up, for example, like in every dirt like that, mm-hmm. open it up, the north will be the center point. And then the continents will just be spread out this way.
Okay, so what do you mean the north? Just so I understand.
So the north, we'll say, will be this right here, the center point, because that's the top of the globe, right? That will be the top. But if we open the ball, for example, like that, the north will be at the center, right? Okay. So now you'll have Asia on this side of the north, and then you'll have America on this side of the north, right? So instead of you going around a globe, what you're doing simply is just going straight lines like this. So you're going from here to there, but it's just simply opened up. So instead of you believing you're going over a globe, you're just simply going across the way. So you're still taking the same coordinate system, except you're not going over a bump. You're just going straight. Like you said, we travel in straight lines. The shortest distance between 2 points is a straight line. And
so my last question is, do you think there's an end to the Earth then?
Yes, there is. A lot of people like to kind of mock that there's an edge, you're going to fall off the edge, right? But in my opinion, there's an end to the Earth because the Earth is being physically contained. Because the second law of thermodynamics, I don't know if you've heard of entropy.
I think I've heard that.
So if you have two opposing gas pressure systems next to each other without a solid barrier separating the two, there's always going to be equilibrium, because high pressure always moves to the lower pressure until there's equilibrium. So that's the law of entropy, right? So they're claiming outer space is a negative pressure system next to the Earth's pressure without a solid barrier separating the two. So they're claiming gravity. Again, I'm telling you, gravity is the explanation for everything. They say gravity is pulling the air in and preventing it from rushing into space. Because again, entropy would just show that the air will instantly just rush into space to fill in the void unless there's a solid barrier. So in my opinion, the Earth is being physically contained somehow. So the air is being physically contained as well. So you'll reach the end of the Earth if you just go south, in my opinion. So what does this wall look like, in my opinion? What does the container look like? I don't know. I have no clue. So the Bible does talk about it, though. They call it a firmament. And they talk about what it's made out of, supposedly, and all that. But in my opinion, nobody knows what it's made of.
Okay, I think maybe my last question might be, like, for other planets you see, if you think they just happen to be circular, like we can it's just like just by design that way, that we have that perspective rather than...
Sure. Why do you believe that planets... let me ask you this, actually, before I assume. Do you believe planets and, like, the stars are, like, other Earth-like planets?
I think that maybe there's some Earth-like planets somewhere else, but I do believe that other planets or spherical shapes exist. And I've had telescopes, myself. We can like, be fortunate nowadays have the technology to actually see them ourselves. Yeah. So let me show you what the stars actually look like, because a lot of people say bring up the stars as some kind of. Or mainly like planets in particular.
Sure. So these are the planets. I was going to show them too. So first of all, talking about the lights in the sky is a red herring when it comes to the shape of the Earth, because it's completely irrelevant. So again, talking about the geometry, looking at the lights in the sky tells us nothing about the geometry of the Earth we're standing on. A direct physical measurement of the Earth is what's required to see if it curves or not, right? But this is what the stars look like, and this is what the planets look like. So not only should we not be able to zoom into them this close and bring them into focus, because they're claiming these are like 3 light years away, it's like trillions and trillions of miles away. So using an 82 times zoom camera, which is what we use here, we shouldn't be able to bring these stars into focus like this. Not only that, you can see that the stars are literally just lights that change color, and it looks like they're twinkling in the water. So the planets are no different. They're just lights that look like they're rippling in water. So again, the Bible does talk about, the waters above from the waters below. So there could be water outside of the Earth system, in my opinion, and not a vacuum of space. So nobody knows what these actually are. Nobody's actually been to them. They claim they have, again, but nobody can verify that or prove it. In other words, they can only make claims about it and just show us CGI about what's in outer space, because everything about outer space is CGI. Nobody's actually been outside of the Earth system, again, because it's a closed system. It's a physically closed system. They're claiming they're doing the physically impossible and going outside of the Earth and taking pictures of the whole thing, and all that's physically impossible. Nobody can go high enough to take a picture of the Earth as a whole. There's a limit to how high we can fly because of air pressure. Differences in air pressure. Airplanes and aircraft require to push off of the air to gain lift. So the higher you elevate, the less dense the air becomes, so the less you're able to push off of it. So eventually you reach the limit of how high we can fly because of the changes in air density. So they're claiming they're going beyond that. Again, they're just making a bunch of claims that defy physics, and they're just showing us cartoons. But again, the stars have nothing to do with the shape of the Earth, but at the end of the day, nobody knows what they are, So that's the reality. So before you guys go, you guys heard of flat Earth, right? So I'm gonna give you guys a huge tip, because when I first came into this, I was all into flat Earth and all that as well. Turns out flat Earth is a psyop, and I'm gonna tell you why. Because over 95% of flat earthers claim the Earth is motionless. So they deny that the Earth is pushing up. So the number one proof that debunks the globe, which is the upwards push of the Earth, flat earthers are defending now. So now they're claiming the same thing as the globe. They're claiming objects accelerate down in free fall without a measurable force. So now they're coming up with their own theories about why objects go down. But it's because objects don't go down. It's the Earth that comes up. So now flat earthers, again, are no different than the globe. So they're having a false dichotomy. They're having a false debate with the globe. So that's the mainstream debate that's going on. They're both like Democrats versus Republicans. They're both being controlled by the same entity, in other words. So that's all a distraction, in other words. So the Earth is level. So that's the difference. The Earth is not flat. It's level. It's level because it's in motion. This is literally pushing up. And level is an orientation. you know, of the Earth. So the Earth is orientated level perpendicular to its motion. So that's why the Earth is level, you know, not flat. So, I mean, any other questions before you guys go?
No, that's all. Thank you.
Yeah, I appreciate that, man. Here, take my channel. I go to UCLA, USC, and I go to other. Here, I'll give you one too. There you go. And I appreciate the chat.
All right, appreciate your time. Thank you.
Take care.
You too.
Have a good one. You too. You know, so. What's up, man?
Dude, how are you?
Doing good, doing good. So, first question: do you trust your common sense?
Common sense, like
Just like crossing the street, for example,
intuition,
like just like knowing when to cross the street. Like, do you trust your eyes when a car's coming and knowing not to cross the street, for example? I mean,
I think I would.
right? I mean,
I think I would.
I mean, it's
like,
like
it could
literally
be situational too.
yeah, but I mean, it's what literally keeps you alive. You know,
That's
at the end
true.
of the day, your common sense tells you not to breathe water
Mhm.
because then you're gonna drown, right? You avoid stuff like that. You know,
Experience,
you know, you could say is the best thing for common sense, to build your common sense, right? Exactly. All right, perfect. So these are very easy. So I have a box truck here, 3 box trucks, and it's completely sealed, you know, just to make the point. But I have a bowling ball inside hanging from a rope inside of the box truck. So one box truck is at rest, one is accelerating forward, and one is accelerating in reverse. So which one of these 3 is at rest?
I think that it would be this one that's in rest.
Yes, it is B. And why would you say B?
The bowling ball isn't moving.
Yes, exactly. It's pretty easy. So which one's accelerating forward?
A.
Yes. So how do you know it's A?
Newton's. I'm literally taking physics right now. I should know this. I think it's Newton's first law: object stays in rest when there's no forces acting on it.
Sure.
So it's like the car is moving forward, but the bowling ball is attached to the string attached to the car. So if the car is moving forward, the bowling ball is going to stay there until the string pulls it forward.
Yes. So the bowling ball's being left behind due to inertia.
Mhm.
Yes. So you got it. That's pretty good. Pretty good. So the ball's being left behind until the string pulls it.
Yes.
Exactly. So this second one, similar, but instead of a bowling ball, it's a helium balloon tied to a string. So out of these 3, which one is at rest?
Should we be?
Yes, it is. And for the exact same reason as the first one, obviously.
Exactly,
Yes.
yeah.
So which one's accelerating forward?
I'm going to say A.
A? Okay, it's actually C in this one.
Is it really?
Yes, so the reason why is because obviously the air inside the box truck is more dense than the helium.
Mhm.
So when I apply a force in this direction and the box truck accelerates in this direction, all of the air that's inside trapped in the box truck is also being pushed in
Yes.
that direction through space. And because air is more dense than helium, is able to push it in that same direction that the force was applied.
Really?
Because the air is moving through space. So it's able to push the
okay.
helium. So I can demonstrate that here, look. Here's a ball that's buoyant inside of a water container.
dense than water,
Less
yeah.
dense than
Yeah.
water, exactly. If I apply a force in this direction, what direction do you think the ball is going to go? Front or back?
From the example, I think it's going to go to the...
Yes.
Wow.
Yeah. So again, because water is more dense, it's able to push it in the direction of the force.
That's pretty cool.
Yeah. I actually didn't even know that till like the last few years that I actually came across that.
Dude, literally, this is my final physics course I'm taking right now.
Yeah.
I didn't even know that.
No, yeah. So you're taking physics.
Probably should have known that.
No, yeah. This is all about physics, basic physics, because you can explain this to a child and they'll basically get it.
Yeah.
It's not complicated,
Yeah.
right? So here, I did this experiment myself in a cargo van with a helium balloon and an apple instead of a bowling ball, but they're both tied to a string. What direction would you say I accelerated here?
You
To the right?
accelerated to the right.
Exactly.
Dude, that's crazy.
Yeah. So here, I did it in a smaller scale. So matter always reacts to acceleration,
Mhm.
and it always shows you the direction too that it accelerates. Because look, here is a water container with a steel ball and a
Same
pink,
thing.
Same thing.
Wow.
So it accelerated in this direction.
That's awesome, dude.
Yeah. So last one, I had a water bottle like this with a ping pong ball and a steel ball as well. I was holding it at rest like this, but I only accelerated one of them down. So out of these 2, which one did I accelerate down vertically? The one on the left or the one on the right?
You said you accelerated downwards?
Yes, downwards. Vertically.
I'm going to say the right one.
Yeah, the one on the right, exactly. Because again, we get the buoyant object being pushed down in the direction of the force, and then the steel ball
Distance in the water.
is being left behind. So the steel ball, again, it appears to go up, but it's because the bottle's moving down.
Got it,
Exactly,
got it.
right? So this one, on the other hand, if I was holding this, for example, at rest, and I just simply released it into free fall, do you believe gravity pulled it down to the earth?
Yes.
Like the whole, right? So the one on the left was actually that. I actually just released it into free fall, but we see that matter didn't react to any acceleration in free fall.
Mhm.
Because I don't know if you knew, gravity is just a theory. So a physical downwards acceleration or a physical downwards force has never been measured or detected. So that's why gravity is just theory. So there is no pressure in free fall. So because when you accelerate something like this, you create pressure in the water, and then that pressure.
Yeah, same thing with air movement. Yeah,
yes.
It creates negative
so,
pressure. Yeah.
So acceleration creates pressure, but here in free fall, there is no pressure. Zero pressure actually. So that's why gravity is just a theory, and that's why they only have explanation. So what's happening there, right? So if we understand buoyancy, it always follows the direction of the real force.
Yeah. I remember that. Yeah.
Yes. If a helium balloon's here on Earth and I release it, what direction does it go? Where do you think it goes up?
Less dense than air.
So the air is pushing it up, right?
Yes.
So in this example, it was the truck that generated the force to push the air in this direction to be able to push the helium. What's generating the force here on Earth to be able to push up the air to be able to push up the helium?
Gravity.
It is gravity, but here's the thing. Gravity is actually a push of the Earth, not a pull. So they tell us that
a
push, yes. So they're telling us gravity is pulling us down, but the reality is the Earth pushing up against you right now. So the reason why we're stuck to the Earth is because the Earth is constantly pushing up right now.
Oh, like normal force.
Yes, the normal force. That's what they call it. But that's the only force that actually exists that can be measured. So gravity as a force, the pulling force doesn't exist. So the reality is when you release an object into free fall, it's not the object that moves down to the ground, it's the ground that moves up to the object. So everything's moving up through space right now. So when something's not connected to the Earth, if the air's not dense enough to keep pushing it up like a helium balloon, then the air's just going to go through it. Mm-hmm. And then the Earth eventually is going to crash into the object. So the Earth is literally moving up, and that's what gravity is in reality.
Awesome.
Yeah. So here, let me ask you this, because this is the real reason why I'm doing this. So you believe the Earth is a ball, right?
Sure. Yeah.
So you understand that on a ball, up is relative. In other words, if you're standing here, up is in this direction, but if you're standing down here, up is in, it's in every direction away from the center. That will be up on a ball. Mm-hmm. If we could prove physically, which buoyancy shows us that the ground is literally pushing up and not pulling us down, how can the Earth move up omnidirectional, in other words, in every direction at the same time if it was a ball? How can the Earth move up if it was a ball?
See, I don't know, because the way that I understand it is that, yeah, sure, I guess you could say that, like, the normal force still keeps us on the Earth in the sense of that, but, like, still, objects still have gravitational pull no matter what. So, say, for example, if I'm going to hold, like, a ball, all right? Yes. The force that I'm exerting on the ball is equal to the force that the ball is exerting on me. That's why my atoms don't go through that ball. Same thing as how if we stand on the Earth, we put a force on the Earth. That's our mass. Mass times gravity.
Yes.
The force that's keeping me not sinking down through the Earth is the normal force. And the thing that I kind of understand is that, like, maybe it's not a push, because I guess you could see it like that. Yes, you could say that because they're equal and they're equal and opposite, then it's pushing.
What you're describing is more of a resistance.
Resistance.
A resistance. So the ground is resisting you being pulled down through it. That's what you're saying, right? That would be the correct word, in my opinion, if you're putting it that way. Not an upwards push.
It could be resistance, but it also could just be explained as equal and opposite.
Sure, but because if something is pushing, that's what I'm saying, if the normal force claims that it's an upwards push, if something is pushing something else, then that object has to be moving in that direction that the force is being applied. So, like, for example, like if I push on this bottle, I have to physically be moving in that direction to be able to push it in that direction. So if the Earth is pushing up, the only way to push up is if the Earth is physically pushing up as well, like literally moving up.
Not necessarily, because in the same sense as, like, oh, you're going to push this, the force you put on it is the same force that's putting back on you. So the force that gravity is putting on you is the same, the force that the Earth is putting on you is the same force that you're putting on the Earth. And I feel like that the way that you can explain gravity is rather than a push, like the Earth pushing against you, it's like gravity is just the idea of, like, big amount of mass has amount of gravitational pull.
Yeah.
So it's like there's pull no matter what, and that's what holds it all together.
Okay,
it's like you have gravitational pull too.
Right. So that's my thing. This whole idea of a gravitational pull, of mass attracting mass, and that creates a gravitational field of a flow of something that's pushing things down or pulling them down. That has never been detected or measured. So I would say that's all cartoon physics, in other words.
I wouldn't think so, simply because there's no way to, like, go around and explain, like, oh, you know, how could it only be us, in the same sense that you could say that about other planets and other kind of stuff like that. Because a gravitational constant, it's still a gravitational constant. Like, for us it's 9.8, but say, for example, on Mars there's different values because it has a different density.
Yeah. So, well, obviously when we're talking about the outer space and other planets, I would say that that's a completely irrelevant subject when it comes to the shape of the Earth, because I know you're just believing everything you're told about outer space and Mars and all that, but at the end of the day, nobody's actually been to outer space. So, and I'm gonna tell you how.
Well, we can see it.
We can see lights in the sky. I can show you what they look like.
Well, not lights. Yeah. Everything around you sees lights. But regardless.
So these are the stars when you zoom in with the optical zoom camera, and these are the planets. So not only should you not be able to bring them into view like this, into focus, because it's only 82 times zoom, and they're claiming these are like 23 trillion miles away. This will show that they're very, very, very close, and it will also show that they're not what we're being told. So the lights in the sky, they change color, and it looks like they're rippling in water. So nobody's actually been to them to physically prove what they actually are. So everything that they're making, any claim about... Yeah.
Something to explain that could be that, you know, obviously light rays can be manipulated.
Yeah.
Light rays going through something, there's different types of reflections and stuff like that. I forgot indexes and stuff like that.
Yeah.
Like obviously you'll see them, they may look like rippling through water, but like go take enough photos, you'll understand that maybe those manipulations aren't the actual planets, it's just the planets going through maybe plasma in space or something like that, like gas.
Yeah.
And either way, like you say that it's irrelevant, but in the same sense, we're still in the same universe.
Sure, but I would,
we're no different an example as them.
Yeah.
So if we see them and we see the patterns that they exhibit, the Earth exhibits the same exact patterns. The only difference is that the Earth is in a specific spot that allowed life to be formed,
right.
and now we're able to observe the world around us and see the trends that they follow the same as we are forced to follow. So it's not like the Earth is an exception. We can be like, oh, the Earth is not just the same example as all of them, because you could. There's no like kind of way to explain how the Earth can be the only sole example that we're supposed to be considering, whereas we can see other stuff around us happening. We can observe that. That's just the same constant. It's the same no matter where you go.
I'm gonna so everything about the tenet of outer space, I agree that that's what they say, right? If there was a way to debunk that they're actually going to outer space, would you be open to that?
If they were to debunk that?
No, if I could debunk that that's physically impossible. So for example, if I want to have a vacuum here, if I want to create a vacuum right here, right? What do I need?
A vacuum?
If I want to create a vacuum.
Remove the gas.
But what do I need before that? Like
a container.
Yes, a container, right? A solid cube, for example. I mean, it doesn't really matter. We'll just say a cube, right?
So long as it has like space inside.
You suck the air out of the container, right?
Yeah.
And not only that, the container has to be completely sealed. That's another thing.
Not allow any gas.
Exactly. So if we create a vacuum right here, right now, with a cube, a solid cube, right? We suck the air out, we seal it, bam. What happens? Obviously, I think you obviously know. If I make a hole on that container, what happens if I make a hole on that container that has a vacuum?
Well, different things can happen. It's like either the container is going to compress or the container is going to be filled with gas.
Yes. Well, obviously, if we don't put enough, if we don't suck enough air for it to be compressed, obviously the air is just going to rush in. Yeah. So we're gonna have equilibrium, because high pressure will move to the lower pressure unless there's a solid barrier separating the two. So that fundamental fact debunks outer space travel and everything about outer space, because they're claiming outer space is a vacuum, a negative pressure system, for example. Not a perfect vacuum, but a near perfect vacuum, right? Next to the Earth's pressure system, without a solid barrier separating the two. So this is where they have gravity fill in the gaps, which again, gravity as a pulling force, it's just a theory, but they use it to just explain away things that don't make sense, like why doesn't the air rush into space if there's no solid barrier separating the two?
The ozone layer.
But the ozone layer is gas, so gas itself requires a physical containment.
But it's ozone, it's not oxygen or nitrogen, it's ozone.
Right. But at the end of the day, that still requires a physical containment for it not to rush into space, into the vacuum.
That's why they call it the ozone layer. It's a barrier that separates the Earth's atmosphere from the pressure of space. And it's not like it's just like, a thin film. But it's like, it's layers and it's...
But it's not a solid barrier, right?
Yeah, but it's gas.
It's gas. So you're saying gas can contain gas, and that gas doesn't need containment itself?
Have you ever had a colander? Like, you know how you can strain out pasta? Yeah, like a colander. Yeah. There's ways that you can fill up a colander with all those tiny holes up with water. Why?
Yeah, obviously because the pasta's covering the holes.
No. Just water. Water inside of the colander. Why are there some examples where you can fill up a colander with water? Why?
You tell me.
Surface tension.
Surface tension, okay, yeah. So what does that have to do with having two opposing pressure systems without a solid barrier separating the two?
Why do water droplets stay as circles?
Yeah, surface tension. Yeah, but what is it?
So the ozone layer carries, to my knowledge, because I heard this and I don't know exactly because I haven't really paid the most attention when we were explaining fluids or stuff like that. But the way that I understand it is that the ozone layer maintains the fact that it's an ozone layer, a barrier that separates outer space with Earth by surface tension, or at least some kind of interaction between ozone that stops oxygen and other things from simply just floating out into space.
Right. So you believe...
And the same way that, say for example, inside of a water droplet, the pressure inside of the water is higher than the pressure outside, on the barrier of the water. Because say for example, the air around us is 1 atmospheric pressure, right?
Yeah.
The water on the outside of the water droplet, that's 1 ATM.
Yeah,
but
sure.
But the water inside of the water droplet, that's higher.
Yeah, sure.
That's gravity. That's surface tension holding that water droplet together. That's the same way that the ozone layer could possibly hold all that gas. And it's not like it's a different example because, say, for example, it's water. There's still molecules and they still have interactions between molecules. So it's not like it's something that's like far off from saying that like, oh, liquid and oxygen just are different. Like, no, there's still molecules interacting with each other. There's still molecule interactions.
Right. So again, this is all falls on the premise again that you're believing that we're being pulled down to the earth, right?
Yes.
Yeah. So not only does matter show that there is no physical downwards acceleration, because acceleration, would you agree that acceleration requires a force? In order for something to accelerate, you need a force to accelerate that.
Yeah, because it's a
yeah. Would you accept then that acceleration or a force is going to create pressure? If you accelerate something, you're going to create pressure in order to accelerate it. Would you accept that as a fundamental property?
I thought it was velocity that creates the pressure.
You could say velocity too.
Sure.
No big deal,
Yeah.
right? The velocity, and especially if you increase the velocity every second, you increase the pressure as well, right?
Yeah,
Yeah.
But the thing is too is that, like, say for example, to create that kind of pressure, you can't have constant velocity with zero acceleration and that kind of. I just think that it's more fair to understand the idea that is consistent in the same sense that, like, you know, maybe one day your theory could be proven right, but like in order to tiptoe all around the laws of thermodynamics and all the laws of physics that we go around, you're going to need something stronger than just saying like, oh, just take a look at these pictures, take a look at this and that.
Yeah.
I'm not discouraging you by any means, because by all means freedom of speech is the way the ideas are questioned and that things are developed. That's why I'm here. I'm learning. But like, it's kind of harder to just use simple examples like this where there's no consistent like examples outside of.
Okay, so let me just let me just go back a little bit just to take it step by step.
No worries.
So my thing is my first premise to debunking the pulling force of gravity is that if you have because this is considered an accelerometer. Why is it an accelerometer? Because if you have this container again with different states of matter, in this case it's a buoyant object, if it's at rest and you accelerate it in any direction, the ball is going to react relative to the direction of the applied force. It doesn't matter if you go up, down, left, right. It's because this is an acceleration detection device. However, this doesn't work in free fall. Even though they're claiming a 9.8 meters per second acceleration, which is fast, is 32 feet per second, which is it's pretty, imagine accelerating 32 feet in a second. And then they're claiming that that's happening in free fall without any effects of the acceleration, without any inertial effects or any buoyant effects, in other words. And that's what they're claiming happening in free fall, which defies physics. That kind of acceleration without any effects of acceleration doesn't exist.
No.
Could you recreate that kind of acceleration that happens in free fall in any other vector?
Yes.
Can you demonstrate it right now?
I can't demonstrate, but I know that you can recreate it, and here's why. Acceleration is not the same as velocity. 32 meters per second, that's different than 9.8 meters second squared.
Sure, yeah.
It's
32 meters per second squared. I'm just changing the 9.8 meters to 32 32
but still, because it's squared, it's exponential. So
it's an acceleration.
As you fall for longer, you will reach 32 meters per second, but it's not like, oh, I'm going to drop this, it's going to instantly go down to the earth at 32 meters.
That's what they measured in a vacuum when they dropped the bowling ball and feather. It was supposedly that's what they measured in the first second.
Yeah, with no air resistance.
With no air resistance, exactly. Okay,
Yes.
I'll give you that. But at the end of the day, there's still an acceleration in free fall if you believe gravity pulls things down, right?
But that doesn't mean that all of a sudden it invalidates the laws of physics. If it's like, oh, it's 32 meters per second. No. In a vacuum, they'll fall at the same speed.
Sure.
But the thing is that no, it's not like I'm just going to drop something. It's instantly going to go that. It takes time. That's why it's second squared.
Yeah.
So it's not like that invalidates anything.
So,
it's still valid.
So besides the free-falling object not showing any effects of acceleration, for example, how can you recreate that kind of acceleration in any other vector? Because if I accelerate in any direction, this ball is always going to react. Always. There's no way.
How could you recreate
How
it?
can you accelerate without the reaction of the ball? That's what the kind of force they're claiming is happening in free fall. They're claiming.
Restate the question.
So, when like I was saying, this is an accelerometer, right? Why? Because it detects when I move it.
It reacts to motion.
It reacts to motion, yes. It doesn't react to motion in free fall down.
But it does.
It doesn't.
No, but it does.
It doesn't. The ball.
If it didn't react to motion, then in free fall it would just stay.
No, it appears to go down because it's the Earth that's moving up. So it only appears to go down. It's an apparent motion.
So to say this again.
Yes.
That does react to like motion in free fall. Even though this doesn't move, it's still it's still reacting.
It reacts to the lack of force, if anything. Yeah.
It reacts to gravity because what pulls it down?
It's not being pulled down. That's the whole point. The Earth is pushing up.
But that's not that doesn't still explain the how it's not reacting. Because if it's not reacting, then it would still stay there. Even if the Earth was moving up to it, that means it's still reacting.
Well, the only thing that is reacting is due to inertia. So it's falling due to inertia.
Inertia due to what?
Well, I would say we're moving through a static field. It's not a field moving through us.
So this is pulling the Earth up? So this has gravity?
No, it has inertia.
Okay, so what is inertia? How do you define inertia?
I don't know exactly what inertia is.
That's the issue.
What is inertia? You tell me then.
Inertia is reaction to gravity. It's movement.
Yeah.
Everything has inertia no matter what.
Yeah, everything has inertia. I would say, because they're telling us the gravitational field is flowing through the Earth, right? That creates the push and then the resistance. The fact is, it's the Earth moving through a static medium. That's what's happening. So that static medium is what creates the pushback. That's what gives matter inertia.
See, so explain this to me then.
Yeah.
If every person on Earth jumps up at once, what would happen?
Nothing.
Nothing.
No. The Earth
so the Earth wouldn't move?
No. The Earth will just continue its motion up.
Really?
Yeah.
Okay. See, the way that I find flaws inside of like that kind of way of thinking is that, say for example, every person does jump all at once, okay? And then the Earth keeps on moving through space, but the people at the other side of the Earth, they don't fall down. Because like you said, up is relative. Yeah, so how do they know up is relative even if like everyone else jumps but the Earth is still moving in one direction? How does that define how up is relative? How does that like explain how nothing's going to happen if everybody jumps at once and the Earth just keeps on moving but people still fall down?
You're saying if everybody jumps up, people will fall down? I kind of... Explain to me.
So you're saying that if I'm going to drop this, it's not this falling down, it's the Earth moving up.
Yes.
Say for example, everyone jumps. Obviously, they're going to have to go back to the Earth. But if the Earth is still moving in one direction, how would that explain the lack of gravity?
Oh, so that's because the Earth is not a ball. The Earth is a level plane, and we're all standing on it, and it's only moving through one direction. So that's why everybody's up is the same. So up is not relative; it's singular. Okay, so everybody's direction is up.
Okay, I see that.
Yeah. So here, before you go, because just real quick, this is the biggest one. Well, besides the push of the Earth, you know the radius of the Earth?
Yeah, they can calculate it.
Yeah, so 3,959 miles is the alleged radius of the Earth. You can look it up. Yeah. So based on the radius of the Earth, there has to be curvature every mile, and every mile it has to increase. So using a simple Pythagorean theorem, for example, a squared plus b squared equals c squared, we can calculate for how much curvature there should be every mile. And it turns out that there should be 8 inches per mile squared. So in the first mile, there should be an 8-inch drop of curve. Second mile, 32 inches. And by the third mile, there should be 6 feet of curvature. And you can look this up, on Google. That's right. You can look it up, Google it. How much curvature should it be in 3 miles? It should be 6 feet. Okay. So how do we measure for that curvature, right? There's a very easy way. So if we went out to a giant lake that was miles across, and we build a level structure over the body of water, once the lake is contained and at rest, the surface is going to be parallel to anything horizontal above it, because the physics of water will show that once it's contained and at rest, the surface always forms an equal surface, because it doesn't have the ability to...
See, that's hard because of tides, because of the water.
No, we're talking about a lake. We're talking about the lake. A lake.
Still, lakes experience tides.
Not all of them. Not all of them.
The moon pulls on water.
Yeah, but not all the lakes are affected by tides, for example. So if we went to a lake that wasn't affected by tides, for example.
Okay, that's a very unique example.
Sure, there's a lot of lakes. Only the Great Lakes are affected very slightly by the tides.
Okay.
So yeah, point being is they're trying to tell us that every lake on Earth is bending 6 feet in 3 miles and 66 feet in 10 miles. So if there was a lake that was 10 miles across, they're trying to tell you that the end of that lake is 66 feet below you than from the starting point. Okay. That the surface but that's physically impossible because water doesn't have the physical ability to maintain shapes on the surface.
I definitely think that you should recheck that, because in any sense that doesn't really match.
What do you mean?
That doesn't really match the calculation of circumference, because I also look at right here.
Yes.
You're using Pythagorean theorem. You're using a triangle. Earth isn't a triangle. You can't use that.
But I'm using to measure this gap right here.
See. Okay, then that means you would have
if
to
you
use
want
you'd have to use a different value.
Yeah.
Than
Here, this is the
theorem.
exact curve calculator done in a computer program. The exact curvature. And these are the numbers. So these are the exact measurements of the Earth curve. These are 90. I would say in the first 300 miles, it's 99% accurate.
Okay.
Yeah. So my point is that the 6 feet in 3 miles and 66 feet in 10 miles is all we need, and they have to admit to that being the curvature, because that's based on the radius they're giving us. So
and does everyone agree on that
yes,
value?
Yes. Even globe earthers.
Okay.
Yes. Yeah, you could Google it right now when you leave. How much curvature should there be in 3 miles? It's 6 feet. And in 10 miles, it's 66 feet. And that's like a 6-story building. That's probably as tall as this tower here. Imagine that much curvature in 10 miles. That has never been physically measured.
Here, now I have a question for you before I have to go to my class.
Yes.
What does this change for you?
Well, first of all, I used to be atheist. So I just believed everything I was told, like about evolution and all that. So coming to this realization, not only did I gain my critical thinking skills back, and now I don't just believe things blindly anymore. I make sure I can prove things to myself. But I actually accept that this place was created. it's a creation 100%. Now, I don't buy into any religion at all because in my opinion, all religions are there to just control people. So nobody knows what God actually is and what created this place. I would say the heliocentric model, the ball earth belief, is the biggest religion on earth because it's based on faith, just like any other religion. So every religion tries to tell you what this place actually is and how it came to be. And the globe earth is no different. They're trying to tell you what this place actually is and how it came to be through evolution and the Big Bang. So that's just a religion story. Nobody knows. That's the fact, how this place came to be. But the first law of thermodynamics, energy cannot be created nor destroyed.
Oh yeah, that's the first one.
Yeah. That proves that this place came from something because something can't come from nothing. So this place 100% was created.
Well,
it's a creation.
I have to unfortunately go, my friend. What's your name?
My name is William.
William?
Yes, William.
Nice to meet
Appreciate
you. My name is Brian.
I go to USC, UCLA. You can check out my conversations.
So I do study theology.
Okay.
I am a microbiology major.
Okay.
And I do feel like that you cannot have, I guess, STEM majors without theology, because theology is the father of all sciences. In order to study the world around us, you have to study who created the world around you.
Okay.
And that's just my opinion.
Okay, fair enough. I'm glad you're saying your opinion.
To be honest, everyone here speaks their opinions, and that's something that everyone is free to do. And I love that so much. I enjoyed this conversation. But I do feel like that in order for you to even believe the theories that you have to have faith. And I do feel like that sometimes it is easy to get caught up in things that may not be the ultimate goal of, the ultimate goal that leads you to find the best version of yourself.
Fair enough.
And I'm only saying that because I have the best intentions, my friend. I'm not trying to insult or anything by all means. I can disagree with you. It doesn't mean that I have any kind of hatred for you. That's the one thing that people have a lot of misinterpretation. It's like I can disagree with you, but all of a sudden I have to hate you. Unless that works. But I do feel like, my friend, that I'm not trying to go into this because there's so much that I can say, but I do have to go.
Okay, before you go, I guess, real quick, just one last question for me. Do you think it's possible that we have been lied to about the nature of the Earth, or are you 100% convinced that it is a ball?
I do 100% believe that it's a ball, and I do not think that everything that we hear is a truth, but I do feel like you have the right to search for yourself.
So you don't accept everything is what you're saying, that you're told?
No. There's a majority of things that I do accept, such as the theory of evolution, because it's not invalidated by the Bible. Okay. The Bible says the earth was created in 6 days. Later, and then it says 1 day for God is like thousands of years for us. So it's not like you could go, God could have created the Old Testament and then all of a sudden been saying no, first we actually started from single cell life, but you guys don't have to understand that. You guys are still outside of the wild. You guys got to go find the Holy Land. That wouldn't really work. So there's a lot of things that are explained, and there are a lot of things that aren't explained. And I feel like that the secret to finding the best version of yourself and finding happiness is to accept what you can accept and then learn what you can learn, because you aren't made to understand everything. That's not what a human being is.
Fair enough. We can learn everything, that's for sure. I accept that.
And there's some things that maybe you can just leave as a question. There are some things that you can find as an answer. It's not like everything is meant to be answered.
I think I 100% agree with you, but I think you kind of have it backwards there, because you're saying that you need to believe in something in order to accept what's real first, I guess, right? That's what you said.
I'm just saying in my mind, the way that I see it, and the things that I study, and the ways that I have read and learned myself, I feel like there are things that you can believe in that will lead you to a better version of yourself, and there are things you have to find for yourself. So it's like maybe there isn't an answer that's written somewhere, but you just have to understand that maybe that's just the way it is.
I guess when it comes to physics or natural science, in other words, things that we can play with in 3 dimensions, things that we can manipulate, right? I don't tend to have beliefs about things about that anymore. In other words, when it comes to natural science, it's either I know or I don't know. I don't place blind faith anymore when it comes to science.
Really?
Yes, I don't. So again, I can build theories off of the practical. So let's say I'm building something and understanding how matter behaves, for example, building a computer, right? Then I can extend that knowledge to, okay, maybe if this happened, I can theorize based on practical examples to better technologies, right? I can theorize there. But if I'm making theories about assumptions that are backed by nothing practical, then that's where I lose the plot. That's where it's not science anymore. That's where it's pseudoscience. Because if your explanations and theories are not backed by practical references, then it's bullshit. But I'm all about advancing theories and making technologies better, but they all have to be rooted in the practical, in what reality shows. In other words,
there's a lot inside of the world that you won't find in practicality.
Well, I would say that's subjective. That's
exactly. That's my opinion.
This subject, in my opinion, is objective. The Earth being a sphere or not, it's an objective question because it's physical.
Do you have a family?
Yes.
You do?
Yes.
When you go home to your family, and say all of this turns out to be true,
yes,
what will you do next?
what I'm doing now. Trying to spread it as much as I can.
But it comes out as true. Everyone now believes it. What are you going to do then?
Oh, well, then that's where we have a bunch of different minds coming together to build communities that benefit everyone, opposed to having a hierarchical structure that we live right now, where we just follow orders and we're all being taken advantage of. So it's about creating a better life after that. I would say exploration, though. Exploration first of the Earth. Fully explore the Earth, and then we can do that.
There's GPS. They're never going to be done exploring the Earth. But, like, I'll pray for you, man.
All right.
Have a good
Appreciate
day.
it, man. You
Thank
too,
for the
man.
conversation.
Yeah, appreciate it, man. Thank you. Want to give us a shot? 2 multiple choice questions that have to do with common sense. All right. Do you trust your common sense? I guess will be the first question.
Yes.
Yeah? All right, cool. So, oh, it's not this one. Oh, it's already right here. Okay. So I have 3 box trucks here, and they're completely sealed. You know, it's closed up and everything. But inside of it, there's a bowling ball hanging with a rope inside. So 1 box truck is at rest, 1 is accelerating forward, and 1 is accelerating in reverse. So out of these 3, which one is at rest?
Which one's at rest?
Yes.
Wouldn't it just be all of them?
No.
I mean, if the bowling ball is not actually being forced to do anything, and it's just the string that's moving with the truck, wouldn't the bowling ball be at rest?
Well, that's at a constant velocity. I'm talking about 1 is at rest, 1 is accelerating forward, and 1 is accelerating in reverse.
But without any of the variables, how am I supposed to say that this one isn't still moving forward, but this is the point in time it was captured at?
Oh, well, that's the thing. It's not constant velocity. The question is, if one of these 3 was at rest, which one would you say?
Is the truck at rest?
Yeah, which truck is at rest, would you say, out of these 3?
All 3 of them?
You think they're all... So you can have a truck at rest, and you think the bowling ball is just going to stay in the back like that?
Well, that's the thing, is if we're talking about the truck, then I can say all 3 of them arguably at
No,
the
I was
same-
talking about the truck.
But if you're saying the bowling ball...
No, I'm talking about the truck. Which one of these trucks is at rest?
It could be both of them, or all of them.
You think they could all be at rest?
Well, what if the truck...
How can this one be at rest, I guess? I mean, maybe if it was
If it's
parked on a
parked
hill.
like this?
Yeah, in a hill. Okay, they're all level. Let me just rephrase that. They're all level. One of them's at rest, 1 is accelerating forward, and 1 is accelerating in reverse. So, on a level surface, which one will be at rest from these 3?
That one.
Yes, that's the obvious one, right? Yeah. Which one will be accelerating forward on a level surface? I mean, I don't think that really matters. Yes, why is that one accelerating forward?
Because as you move, the bowling ball is going to stay at rest until the rope starts pulling it.
Yes, exactly. So due to inertia, you know. So yeah, you got it. All right, perfect. So that was the first one. So you get it. So the second one, pretty similar. Again, level surface, same scenario, same everything. The only difference is instead of a bowling ball, it's a helium balloon inside of the box truck. So which box truck is at rest?
Same logic.
Yes, same logic, exactly. Which one's accelerating forward?
That one.
This one's actually C. And the reason why it's C is because the air is actually more dense than the helium that's inside of the box truck. So when you accelerate the box truck forward in this scenario, the air that's inside the box truck is also being pushed forward in that same direction. And because air is more dense than helium, is able to push the helium in that same direction of the force. So that's why it's C, you know. And I can demonstrate that with this buoyant object here. So this is a buoyant ball inside of water. Obviously the water's more dense. If I apply a force in this direction, what direction will the ball go?
Well, if you're arguing for that, then it should be moving that way.
Yes, and it does. You know, so that's what happens in reality. You know, something is less dense than the medium that surrounds it. Depending on the direction the medium is moving, that's the direction that the buoyant object's going to get pushed. You know, so here I did this experiment myself in a cargo van, and I want to see if you could tell what direction I accelerated. So instead of a bowling ball, I used an apple, but same principles. What direction would you say I accelerated here? To the right or to the left?
To the right.
To the right, exactly, because that's the direction that the air is pushing the helium. Meaning the air, it's being pushed in that same direction as well.
So are you a physics major?
Not a physics major, just physics enthusiast, you could say. So here I did it in a smaller scale with a container like this, with a ping pong ball and a steel ball. So inside of water, but in different states of matter, but same principles. What direction they accelerate, to the right or to the left? Which one would you say?
Oh, No.
Exactly. Yeah. All right, you get it. So matter will always react to an acceleration. That's another thing. And buoyancy will always follow the direction of the force.
Okay.
Yeah. So last one, I had a water bottle like this with a ping pong ball and a steel ball, but I only accelerated one down like that vertically. So out of these two, which one would you say I accelerated down vertically? The one on the left or the one on the right?
That one went down.
Yes, it was this one, exactly. Because again, the buoyant object got pushed down in the direction of the force, and then the steel ball got left behind due to inertia. Because obviously the water wasn't dense enough to push it down like it did the ping pong ball, it just got left behind. So let me ask you this. If I have this object like this and I have it at rest and I just simply released it, do you believe gravity pulled it down?
Only, yeah.
Yeah, right? You believe that everything accelerated down to the earth, right? From being at rest. So the one on the left was actually free fall, but we see that matter didn't react to that acceleration like it did in this one. And the reason why is because, I don't know if you knew, gravity is just a theory. So a pulling force of gravity has never been actually physically measured or detected.
Well, I mean, it's not a theory. It's called the law of gravity.
What's it?
The way science works is that if you can prove that something, if you were to drop it, floats up, then it becomes a theory, and then they have to do the math to prove that that is not a law anymore.
Right. Well, the law of gravity is not called a law of gravity. Because you've heard of the Einstein's theory of relativity, the bending and warping of space-time.
Yeah.
So that's a theory. And that's the theory to explain why objects accelerate down without any effects of acceleration. Because, again, acceleration will always require a force, and a force will always cause pressure. So that pressure is what pushes buoyant objects in a particular
Are you
direction.
familiar with anti-realism?
What is that?
It's a school of thought in quantum physics where they believe that there's multiple branches of how quantum physics works, and then one school of thought is that anti-realism is how quantum mechanics works, and the fact that we perceive it, and so it is real. So, say it was nighttime and it was a full moon. The moon does not exist because I'm not currently looking at the moon, but once I do look at the moon, it does exist.
Okay.
So
that's kind of.
But what you're arguing is perception of this science, right? So
it's not just perception; it's it's physical as well.
Okay, but let me ask you this.
Yes.
Going off of anti-realism, if you weren't looking at it, can you say for sure that gravity wouldn't be doing what it's said to do, as you were saying?
I would say there's a different thing that's happening that can be demonstrated and repeated. So something that can actually be proven it's happening, other than a pulling force of gravity.
So then what is it?
So if we understand buoyancy, we'll always follow the direction of the force, and that can be demonstrated here on Earth. If I have a helium balloon here and I release it, what direction does it go? Why do you think it goes up?
Why do you think it goes up?
Because it's less dense than the air, and the air is able to push it up. Would you agree or disagree with that?
So then what are you saying about us then?
So what's pushing up the air to be able to push up the helium? Because in this scenario, it was the truck that created the force to push the air, to push the helium. What's creating the force here on Earth to push the air up, to push the helium?
But what's also keeping the Earth from not going downward?
What do you mean?
If you're saying that the way that gravity works, if you're redefining the terms of gravity and the fact that it's density, and that if there's a less dense object, it'll move up versus down, what's to say that the Earth is not less dense than space, which is absolutely nothingness, right? So why wouldn't we just be free falling downward?
Oh, you're talking about why isn't like...
Well, think about it. You were just saying how in this diagram over here, the steel ball was not moving because it was free fall, right? So if we are moving downward because of buoyancy and the fact that there is absolutely nothing, and that we are a denser object, and we as in the planet, right?
Right.
So, are we moving down?
So the density layers don't just create themselves based on the density differences. It requires an external force to dictate the density layers. So the force of the Earth is not a pull, is a push.
Okay,
so that's the only difference.
Sun?
So the sun and the moon are completely... When we're talking about...
Moon, the sun.
Well, the sun, I don't know what the sun is. And if I'm being honest, nobody knows what the sun is. That's the reality.
If you're going to redefine the term for one celestial body, it has to be the entire system that's a part of it. That's why we call it the solar system.
Well, let's stick to the Earth first, and then we'll talk about the sky. But talking about the Earth, so the buoyancy, obviously, the helium balloon will rise because it's less dense than the air, which is pushing it up. So the Earth itself is literally moving up, which is pushing up the air, which is pushing up the helium, and that's why we're stuck to the Earth, is because we're not being pulled towards the Earth, it's the Earth pushing up against us. So that's where they flip the script of what gravity is. So gravity is the motion of the Earth. That's what gravity is, a push of the Earth.
You're also talking about how the fact that there is a specific limit in the sky where West helium balloons will not go up, right?
Yes, because the density, it equilibrates with the density up there. Because it becomes the same density, so now that air's not able to push it up further.
Okay.
Because only that something that's more dense can push something that's less dense.
So what about the stable?
What about it?
Well, what about it? I mean, isn't it more dense?
Yeah, so if we put it in the air and release it, the air is not dense enough to push it, so it's just gonna fall. Anything that's more dense than the air.
This?
Yeah, it's more dense than the air.
Is this more dense than the table?
It's less dense.
So it's less dense.
Yeah.
So arguably, this is going to fall at lesser rate, right?
What do you mean? It's gonna fall at less gravity? You're saying?
So like,
Yeah.
it's falling, right?
Yeah, it falls.
All right.
But that's not because it's actually falling down. It's the Earth that's moving up.
So the Earth is moving up.
Yes,
so,
and that's why things appear to go down. They only appear to go down, but physically they're not. It's
All right,
the Earth
let's
that's moving up.
Go more macroscopic.
Yeah,
Right.
sure.
Going back to what I was saying about the Earth, right? So
Sure.
rather than going down in free fall, you're suggesting that we're moving up.
Yes, yes, and that's what gives us all the effects here on Earth.
Okay.
From
and
weight,
so
buoyancy.
What
everything.
about people that are in the Antarctic right now?
Okay, I was gonna get there. So you believe the Earth is a ball, right? Obviously, right? So you understand that on a ball, up is relative. So if you're standing here, up with this way. If you're standing down here, up is this way. In every direction away from the center will be up on a ball.
Because of what?
Well, that's because of gravity. It's the opposite direction of gravity. And theoretically, right, on a ball, up is relative, right? That's my point. But if we could prove that gravity is not a pull of the Earth, it's actually a push, and buoyancy shows us that, how can the Earth be moving up in every direction away from the center if it was a ball?
Can you restate that?
So if we could prove that the ground, the Earth, is literally pushing up and not pulling you down, because buoyancy shows us that. So, if we could prove that, how can the Earth move up in every direction away from the center if it was a ball? How can it move up?
What you're describing now is that if I were to be in the Antarctic, I'm a buoyant object compared to the air.
No.
Because if, say, whatever shape this is moving upwards and I'm here, in order for me to continue moving with it, I would have to be a buoyant object.
You, in my opinion, because you're more dense in the air, if it was a ball, people, if it's moving up like that, people in the bottom of, relative to the people on top, would just get left behind.
But what you're describing is the fact that if I'm here,
Yes.
and then suddenly I find myself here, somehow in between that point of travel, I'm less dense. Because if your planetary body's moving upwards, and I'm more dense than the air that is in the atmosphere right here,
Yeah.
that would suggest that I'm less dense when I'm here. Otherwise, I would be at the bottom of the atmosphere, because the air should be rising up, which to say is that everything should rise up like it's a balloon around the Earth. So there should be no atmosphere below here at all.
Right, right.
So everything should be dead right here.
Yes. So here's the thing. If we could prove that it's the ground physically moving up and pushing up against you and not pulling you down, then that would mean, from a globe Earth perspective, the Earth will have to be expanding to be able to push up in every direction away from the center.
Everything's expanding. That's how the universe works.
Which means the Earth will have to be growing by the second, and it'll just explode.
But is the Earth growing, or is it the universe that's growing?
Well, they say the universe is growing. They don't say the Earth is growing.
They say?
Physically. Scientists, astrophysicists. No, that's what they say. That
No, but what do you say?
What I say is that if we could prove that it's the ground pushing up and not pulling you down, that would debunk the globe Earth theory, because in order for people to believe in the ball Earth theory, they first have to believe in the theory of gravity and the
you're saying
pulling
the universe
force.
is not expanding, right?
I don't know what's outside of the Earth.
You're saying that the universe is not expanding, but rather that the celestial bodies are themselves, right? Otherwise, we'd be crashing into Mars and Venus and everything else, right?
Yeah. Well, what I'm saying is that in order to believe in the ball Earth, you have to believe in gravity being a pulling force. Because if we could prove that it's a pushing force, it wouldn't work from a globe Earth.
If this container were the universe, right?
Sure.
And then this is your Earth, and it's expanding.
Sure.
That means that we're going to break out of this container at some point.
Yes.
So you're arguing that right now we're inside of a box.
I'm arguing right now that the Earth is not a ball. It's actually a level plane, and we're all standing on the top of a topographical plane, and
So
it's
you're
moving in
arguing
one
for a flat
direction.
Earth.
Not flat Earth. Flat Earth is a psyop too. I'm actually exposing flat Earth as well. So the Earth is a level plane, and it's only moving in one direction through space, which is up.
So you believe it's just a plane of existence and it doesn't
Yes.
have shape?
I don't know the exact shape, because I would say that it's not infinite. The Earth is not infinite. So if you go in one direction, you're eventually going to reach the end of the Earth.
So arguably, like the first edition of Mario, if I walk off the map over here, I'm going to come back around over
No,
here.
that's like the Pac-Man theory that I've heard of other flat Earth. No, you're going to reach a wall. You're going to reach the container over
But
there.
that's what you're describing with the plane, right?
Yeah, the
if
plane.
I keep moving this way,
You're gonna
inevitably I'm gonna come back
No.
around facing this way again.
no. You're just gonna reach the end of the Earth. You're gonna reach
the end of the Earth.
Yes, like some kind of container. I don't know what it looks like, but in my opinion, the
That does
government.
sound a bit like flat Earth talk.
No, it does sound a bit like flat Earth, but here's the difference. Over 95% of flat earthers claim the Earth is motionless, so they deny the fact that the Earth exerts a force. But
Well, I mean, we're not really describing their physics of it. We're just describing how they see the shape of it.
no, but here's the difference. Motionless flat Earth is not different than the globe Earth because they believe objects accelerate down in free fall as well.
You align yourself with science, right?
Yes,
But
practical science,
But you
yeah.
don't align yourself with all science, right? Like gravity.
Well, gravity is. I wouldn't say is natural science. I would say it's
But you're
formal
not
science.
aligning yourself with it, right?
No, I only align myself with natural
So,
science.
if the flat earthers are, advocating for a shape,
Sure.
but you're not advocating for all of their sciences,
Yeah.
except for the fact that we live on a linear plane, right?
Sure, a horizontal plane.
Excluding mountains and other such things,
Yes.
like the tree that's right over there that's
Yes.
clearly taller than us, right?
Yes, horizontal plane.
So technically you are in fact a flat earther.
No.
But you just don't advocate for all flat earthers. Just the same way that you're not advocating for all science that's
No,
publicated.
no. Flat earthers, again, they're no different than the globe because the number one proof that debunks the globe is the fact that the Earth is pushing, not pulling.
Okay.
Because gravity requires that pulling force to be a belief in order
How
to
do you
explain.
describe time?
So time is just a concept based on the motion of
Well,
the
yeah,
sun.
time is a constant.
Based on the
yes,
motion of the
but
sun.
there is a general idea that we've constituted for its speed, right?
Well, again, it is relative to motion. Yeah, in this case, our time comes from, our calendar comes from the motion of the sun.
The motion of the sun, and how does the motion of the sun affect us?
I don't know how the sun works, and nobody knows. That's the reality.
But that's not what we base our time off of.
It is the motion
The
of
space-time continuum, how the speed of time flows, right, is because of what?
You tell me.
Gravity was.
So pulling, bending and warping of space-time is what you're saying.
Pretty much, but
So a theory.
But what happens
Yeah.
is gravity is the one that's stretching the continuum.
Right.
So in order for us to have this passing time right here, there has to be gravity.
Sure. So how have you verified this, if I may ask? Like, and I've heard these claims before about bending and warping of space-time, and all of these.
I took an apprenticeship under a physicist.
And then how did you prove it to yourself? If I may
Can I
ask?
prove it to myself?
Yeah.
I can't. It's beyond my perception
Oh.
because I'm a third-dimensional creature. But
Would you say it's based on faith then that you take these claims?
God no.
Because when it comes to natural science, in my opinion, faith has no place in there.
The way I see it is this:
Yes.
I caught it because it went down.
No, you caught it because you went up to it.
I didn't go up to it.
Yes, you did.
Hand stay still.
Yeah. Yeah, you went up.
It hit my hand.
Yeah, because it started to slow down and you just came
So
up
what
to
you're
it.
arguing is that everything that's in the air is free falling.
If it's not connected to something that's connected to the Earth, then yeah, it's gonna be free falling.
So if my hand does not exist, it's free falling right now.
Yeah, it's gonna free fall, but it only looks like it goes down, but because everything else is moving up.
But you just said that everything's expanding.
No, if it was a ball Earth, then it would have to expand. In my opinion, matter cannot expand into infinity. That's
So
retarded.
you're not saying that the Earth is expanding.
No, the Earth is just moving up in one direction.
It's moving up, right?
Yes, it's just moving up.
Okay, so once again, if I'm in Antarctica, where is this going to go?
Antarctica is just across the way. So I don't know exactly where it is relative to the other continents, but it's just across the way. It's,
Have you ever left the country?
yeah, I've gone.
And how was your experience there?
What do you mean?
Was gravity the same?
Yeah,
Everything went up?
exactly. Because everybody's up is up. Because that's the motion of the Earth.
What happens if I jump?
The Earth catches up again.
So what you're saying is that
You never come back down.
if I was on Mars, right, and say gravity goes down, like not gravity, but Mars goes down, right, instead of up,
Why would it go down, though, if I may ask?
because you're saying that the Earth goes up. So now I'm saying hypothetically, if Mars is going down, because the Earth is going up, and the fact that if I jump, I can elevate myself to about, I think my jumping height's maybe like 9 feet or something like that. So if I can jump 9 feet on Earth, and Earth is going up, trying to catch up with me,
Yes.
if I'm on Mars going down, I'm jumping like 30 feet.
Yeah, I mean, theoretically. But here's the thing. Terra firma planets that they're claiming are outside of the Earth system, aka the stars and planets, this is what they actually look like. Nobody knows exactly what they are. So these are the stars, and they're just making up stories about what's outside of the Earth.
Well, one thing
At the
I
end of the day, nobody
want to
knows.
say is this.
Yeah.
You just said,
Yes.
and you agreed to it,
Yes.
that if I jumped on Mars and Mars was going down, I'd go 30 feet up, right?
Let's just say if the Earth was moving down instead, because Mars is just
what
a
I
light.
want to say is this.
Yeah.
You confirmed it, yes?
Well, I just said it just to hear your point, but in reality, Mars
So
doesn't.
you didn't agree.
No, Mars is not a
You
terra
didn't agree
firma.
if I were to say that Mars was going down,
Well,
and
Mars.
if I can jump 9 feet on Earth, and I jump on Mars, I would not jump higher than 9 feet, right?
Again, Mars.
We're just talking about hypothetically.
Hypothetically,
if,
sure.
If
yes.
Mars did exist
it's moving
and
down.
it was going down,
yes.
right? Okay.
You wouldn't even need to jump.
But what you're describing is the fact that if I were to jump, I'd actually jump outside of Mars because Mars is moving away from me.
That's the thing. You wouldn't even need to jump. If it was moving away from you, you just stand and you just stay floating here, and it'll just move away from you.
But you did acknowledge the fact that I would be on Mars, right?
Hypothetically,
yeah.
If you're hypothetically, if Mars was a planet,
why would you hypothetically condone something against your own theory?
What do you? Okay, well,
if you're
I'm going based on your hypothetical.
A
hypothetical is not real.
Gravity is, us being affected by the movements of the planetary bodies, right?
Well,
so
right
why
here,
would
the
you
Earth itself.
Go with my idea and then agree with the what I was saying.
I'm only agreeing with it because it's a hypothetical. You're saying
well,
that.
yes, a hypothetical, but what you're also saying is,
but in reality, it was not possible.
Well, if I was arguing for you, instead of your response of saying, well, yeah, I would have then said, no, you're not going to jump up 30 feet, but rather, in fact, you are just going to stand still because Mars is trying to get away from you.
Okay, fair enough. Yeah, you corrected me. I will agree with that one.
But at the same time, people who are on the other side, in the South Pole, the planet's moving away from them, and they don't need to do anything, right?
No.
Okay, so then right now millions of people are dying because every time that they go past a certain area, they start falling off the planet.
Well, that's if planets exist. Planets don't exist. The Earth is not even a planet. The Earth is a level plane.
It's a level plane.
It's a plane of existence.
Okay.
And then it's moving up.
So what you're arguing more so is psychology.
Well, it's not psychology. It's physics.
You're applying physics.
Yes, because this is natural science.
Now, I'm going to admit the fact that I don't know everything in physics. That's for sure. Oh, yeah. I certainly, like every physics enthusiast, right?
Sure.
I like to describe it as this. We're all level 1, and we want to read about level 100 stuff, but there's all this in between that we have to really work and spend a lot of time with, right? So that's all the laws that, may go against an idea we have. What if I wanted to use quantum teleportation to transport the information of my body over there, right?
Right.
But then there's Coulomb's law or something like that, I mean, obviously Coulomb's law might not have to do with it, but I'm just saying it in general.
Yeah.
Is that there's something that I might not know that gets in the way with it, right?
Yeah.
So what I'm saying is this. As enthusiasts, we don't know everything, and that's why you see a team of people.
Sure.
So arguably, can you say that you're wrong?
Arguably, no.
You don't think that there's any potential chance at all?
No.
So if I were to say that my shirt is not gray, but rather it's blue, you'd argue against it?
Well, now we're talking about different people can perceive light differently, so...
No. If you and I have the same color spectrum, right?
How do we know that?
Hypothetically, you and I have the same color spectrum,
then,
right?
Yeah, our color should be the same.
You're handed this marker.
Sure.
It's blue. You're handed this marker. It's black. Except for as a kid, you're told that this is black and that this is blue. Even though this is clearly blue and this is black.
Right.
Even though I told you the wrong thing. You're going to walk into kindergarten the next day and tell people that you know your colors, and then you're going to be told that you're wrong.
Okay, sure. The label we put on the color shows it's wrong.
So you're telling me that our colors are wrong?
No, color is what it is. It's just the label we put on.
Color is a metaphor for gravity right now. You're telling me because we were told that everything falls down and that the Earth is a sphere.
Yeah.
So what you're telling me is that when I was taught that this goes down and that this is a sphere, that I was taught wrong.
Yes.
Who taught you?
Reality. Reality is my teacher.
Mm-hmm. Yeah. Can I get their business card?
Well, here I can show you. So this is part of reality. This little this is an accelerometer, and it's an accelerometer because it detects the presence of a force.
Okay.
So the buoyant object will always get pushed in the direction of the force. In other words, in the direction this is moving through space, that will push the ball in that same direction 100% of the time. So in free fall, if they're claiming a downwards acceleration of this whole container moving down in space, then that ball should get pushed down towards the ground, like it did in the example.
But that's density and not gravity.
Yeah. Well, density is created by the density gradient is created by gravity, which is a push, not a pull. Because
what you can argue is the fact that if something is heavier, it's going to push past other stuff to go down, right?
No, it's just the air is not dense enough to push it up, so the air is passing through the dense object, not the object passing through the air.
Follow me here. Say you make a banana milkshake. You ever leave one of those in the fridge for too long?
Sure.
Eventually, the banana is like very light, so it goes past all the water and other stuff, right? Yeah. So you're saying that the lighter weight objects within the container are going to push past these heavier objects.
Well, if they're right on top of it, completely seen, then they can't push past it. But if there's like openings,
Let
then
me ask you
eventually it
something.
will.
If there was someone that was about 3 times my weight and they decided to sit on me, am I going to push past them and go up?
No, but if I
Why not?
put something above this ball, I mean, depending how big it is, if it's like not that big, eventually the ball's gonna get pushed around it. But if it's like a big surface area, then it's just gonna hit the top.
But how can you argue against the fact that something just didn't roll off of it?
This didn't roll off of it? What do you mean?
If you put another heavier object in the way, right?
Yeah.
How can you argue that something isn't just gonna roll off of it?
Sure, my point is, this ball is being pushed up right now. Would you agree or disagree?
I disagree.
You disagree?
Yeah, I disagree.
So what do you think is happening here then, if I may ask?
How does liquids work? Why is the liquid in the shape of this container right here?
Because water doesn't have a form. So it
But
takes
I'm looking at it
it
right
takes the
now.
shape of the container and the
It takes
surface.
the shape of its container. Okay.
Sure.
So, arguably, this buoyancy test is a little bit faulted in terms of, comparing it to your reality of gravity, right? Because the ball, the string, and the stick at the bottom that's keeping it, all together,
Yeah.
that's a part of your container.
Yeah, all of that's part of the container.
So the water is actually forming itself to fit the container.
Yes.
So then, once again, if that's wrong, how can you argue for gravity being the Earth pushing us up?
No, the Earth. So this contains. So you people believe that the water is being pulled down into the container, but is the container pushing up, and the water is just there. So when water is being released in the air, the water's not accelerating down. It's the container that pushes up.
Perfect example right here is that there's an air bubble right here.
Yes.
Okay? So the way gas works is that it's much more freer in terms of its particles than liquids, right?
Sure.
Okay. So if we're pushing up, this bubble wouldn't be as thick as it is, right? Wouldn't it be more spread out?
Well, it is spread out a little bit like that right here.
No, it'd be more spread out than that.
So you're not saying, so you're saying this bubble is not being pushed up?
So what I'm saying is that I walked over here and my perception of the bubble is that it's at state 0 and you've been here and it's at state 5, right? So you're saying that in your perception of this bubble, it's already been spread out. But I haven't seen any such thing. Because we're arguing for perception.
Right.
So, I haven't seen this bubble spread thin at all.
Right. It's being pushed up against the top of the container right now, though.
It's being pushed up?
Yeah.
Or is the water being pushed up?
They're both being pushed up right now.
So
but
the
because
container is pushing up the water.
And the water's pushing up the bubble and the ball.
But then why isn't the bubble spreading thin?
Because you mean you apply more force, probably.
Okay, but say in another container, you know how sometimes bubbles can be circular?
Yeah.
Okay, so then why isn't this circular bubble suddenly becoming a blob for being pushed up? Why is it saying perfectly circular?
You're saying this one's staying perfectly circular?
No, I'm saying that say this blob right here
Right.
was a perfect circle, right?
Sure.
And it had just formed. Why isn't it spreading out into some sort of odd shape to fit, being pushed in this container right now?
Right, because obviously the pressure of the water, too, is keeping it from spreading all the way very, 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 very thin. It's the pressure of the water itself as well.
Spreading very thin, right?
Yeah, it's
Earth is a plane.
Earth is a plane.
Okay, but if 70% of Earth is water, who's to say that argument isn't saying that it's keeping the plane from spreading out? You could say that it is a plane, but in reality, it's being folded together as a sphere because of water, right?
No.
But you just advocated for a container. Why can't it be for the entire planet?
So the container of the oceans and the lakes are just craters. So you know how a lake, if you empty the water from a lake, what are you left with?
You're left with all the rocks.
We're left with the crater, with like a hole, pretty much.
Okay, but once again...
That's the container. So the oceans are no different.
Not even on the other side of the Earth on the South Pole. You could just be on the sides.
Yeah.
Anybody who's not at the exact top and like a certain radius around that would be falling off.
That's because the Earth is not a globe.
But have you been to space?
Nobody's been to space.
No one's been to space.
Nobody. You want to know how I know that?
How?
Have you heard of this?
Tell you?
The second law of thermodynamics, and you know the law of entropy? There's a real law. What's the law of entropy?
It's talking about how chaos is, always in the system.
Yeah, so high pressure will always rush into a lower pressure unless you have a solid barrier separating two opposing pressure systems.
High pressure will always run into the lower pressure.
Yes, because of entropy.
The water has more or less density than that ball.
The water has more density than the ball, yes.
So would you say that it has more force? Because you just said
sure, yeah.
Entropy, we can compare that in an experiment to a system.
Sure.
So if high pressure is running into lower pressure, you just said that the water is running into the ball.
It's pushing up the ball because it's more dense.
No, you just said that it's pushing into the ball.
It's pushing the ball
and
up.
So the way that it's now working is that it's trying to fit the container and, reach the ultimate chaotic state, except for, it's theoretically impossible to reach ultimate chaos because it could get even more crazy, right?
Sure.
So if more high pressure is pushing in and it's trying to fill this container, right?
Right.
Okay.
How are we adding more pressure to this, if I may ask?
Gravity.
What do we do to it to add more pressure? Well, you're just saying gravity. Physically, what do we do to it?
If you're going to argue against one law of science, then you're going to start unraveling other ones where they're intertangled, right? That's the same thing with time.
Right.
And how you also said that our planet is not spherical, but rather a plane, right?
Yes.
So you didn't just touch one area, you touched multiple areas. But I don't think that you're grasping at every aspect, because the way that science is that it's infinite. There are a whole lot of things that you don't know.
Sure.
And that there's a whole lot of things that nobody knows because it's still being discovered, right?
Right.
So if you're saying entropy is high pressure versus low pressure.
Yes.
So that means the high pressure is pushing everything out of the way till it fits this. The entropy of the water versus the entropy of this buoyant ball.
Sure.
So what's happening here is that the water is pushing down.
It's resisting the upwards push because of inertia, sure, we could say that. But it's not moving down. Nothing moves down. It's just resisting the upwards push.
So how are you going to stand up?
I have to use my muscles. I have to use the force.
So
to overcome the force of the earth keeping me down.
But your force is stronger than something that is millions of tons more.
Well, my force just has to be strong enough to overcome my body's inertia to be able to stand up.
But what you're describing is that your force is millions of tons. Hi, Matt! Hey, Matt, come over here.
You already spoke to him earlier.
Well, I mean, it's still.
Yeah, I know, I saw.
You were checking out the live?
Yeah,
nice.
Okay,
No, so here's the thing. The reason why I brought entropy into the conversation.
But entropy no longer is relevant.
No. But here, let me just make my point.
It's no longer relevant.
No, it is
because
relevant.
High pressure can't meet low pressure if things don't go down.
Here, let me see. So you understand that they claim that outer space is a near perfect vacuum, right?
Yeah.
Right. So it's a negative pressure system in comparison to the Earth's pressure system, right?
Mm-hmm.
So they're claiming that the outer space and Earth's pressure system are coexisting next to each other without a solid barrier separating the two.
So
that defies
we have
physics.
The plane right here, right?
Yes.
Where's space?
Well, outer space, as we're being told, what's outside of the Earth, a vacuum, that I don't believe in. I don't know what's outside
of here.
I don't know. I know that we're being physically contained somehow.
Did reality not tell you?
We can't know everything.
But why did reality tell you this and not tell you anything else?
Because I don't have access to outside of the Earth.
So
that's why.
Access outside of the Earth or access to information?
Access to outside of the Earth. I don't have access to go outside of the Earth to see what's outside.
If you don't have access to outside the Earth, but you do have access to a seemingly endless amount of information that none of us have, right? So
no, the information I'm presenting here is practical physics. It's how matter behaves under conditions of acceleration and force.
How did reality tell you?
By playing around with matter. That's how technology was.
Reality played around with matter, or you?
I played around with matter.
You played around.
Yes.
So did reality tell you, or did you figure it out?
I figured it out, but reality was the teacher.
Was
the one showing me, I guess, what's happening.
That's not quite the same thing.
I didn't create reality.
Reality is a perceptual place.
Sure, I didn't create reality.
It's not a physical place, and it's not something that can be personified to tell us things.
We can understand things here in reality.
Understand things, but it's not going to tell us.
Well, understanding,
we're figuring our shit out.
I would say understanding is one step forward to.
But what you're saying is that you figured this stuff out.
Yeah, how matter behaves at a fundamental level.
Okay,
yes.
And do you have anybody who also has figured this out?
Oh yeah, there's plenty of people online. We're the minority within the minority.
Why aren't they here?
They have 9 to 5. The system is keeping everybody down from actually doing this.
You
I have
said
to.
that this is a live stream, right?
Yeah.
So why aren't they like doing like a split screen sort of thing with you?
I'll actually do call-ins.
Oh, I mean, like right now. Why not?
But why would I talk to other people that are?
Because what reality is telling me right now is that only you are here, because only I can see you. That's what I'm being taught by my physical space around me.
You're focusing on the wrong thing. You're
No,
focusing on me.
but
You should be
what
focusing on the.
I can do
examples.
that, but what I'm saying
Yeah.
is that as far as I know, you just came up with this because you were bored.
No. You don't. Would you agree
Prove that.
Yeah, buoyancy.
No, prove that you weren't bored.
Yeah, I'm proving.
How
it.
are you going to prove it?
No, I'm gonna prove that what I'm
But
saying.
you can't take me back to the exact point in which you had this epiphany.
Well, when I had this epiphany, it had nothing to do with me being bored. I was actually fascinated with.
Can you show me the math?
The math for what? Oh, here, I'll show you some math. Do you know the radius of the Earth?
At one point I did.
Okay, the radius of the Earth is 3,959 miles, allegedly. So based on the radius of the Earth, we can calculate for the circumference, which is the distance from the surface all around. 24,901 miles, allegedly. Based on the circumference of the Earth and the radius of the Earth they're giving us, there has to be curvature every mile, and every mile that curvature has to increase. So in the first mile, there's an 8-inch drop, second mile 32 inches, and by the third mile, there should be 6 feet of measurable curvature. How do we measure for that curve, right? There's a very easy way. If we went out to a giant lake that was miles across, and we build a level structure over the body of water, the water on the lake is going to show us that it's going to be parallel to anything horizontal, because once water is contained in at rest, the surface always forms an equal surface, which is level. So they're trying to tell us
How
that the
does it
surface.
form this equal surface, though?
What do you mean? How does it form?
How does it form?
Because
this
water
equal
doesn't
surface?
have a shape. It takes the shape of the container, and then the surface always forms a horizontal.
Same thing with the bubble, though. Wouldn't it just spread itself thin?
Well, like I said, it probably requires more force, or it's because of the because depending on how you hold it, obviously the shape changes too. So the the container has a lot to do with it and how much force you apply.
So at what force do you think that we're being pushed up right now?
I have no clue.
You have no clue.
I have no clue how fast the Earth is moving up.
So
No clue.
you said fast. That's a key word right there.
I don't know the
What
velocity.
if it was slow? You know, like you didn't say slow or
I don't
just
think-
briskly moving. You said fast.
Yeah, I don't think the Earth is moving. In my opinion, I can't prove this, but I don't think the Earth is moving anything less than 1,000 miles an hour.
1,000 miles per hour. So we're being pushed up 1,000 miles per hour.
At least. Again, my
That is
opinion.
a significant amount of pressure right now.
Right. You know
but shouldn't my legs be breaking right now?
You know how fast the Earth is spinning supposedly and moving around the sun supposedly?
Well, it's not spinning. It's a plane.
No, but if it was a globe, because you believe this, you know how fast the globe Earth is supposedly spinning?
Tell me.
Over 1,000 miles an hour. Do you know how fast it's traveling around the sun supposedly?
Way faster.
Over 66,000 miles an hour. Do you know how fast the sun is traveling around the Milky Way? Over 500,000 miles an hour. Do you know how fast the Milky Way is traveling through space? 1.2 million miles an hour. So we have 4 fast motions right now, supposedly on a globe, but we don't feel any but the upwards push.
Okay, and you want to go? I wasn't done. All right, fine. Say hi to reality for me.
All right. All right, man. You guys take care. I appreciate it.